Okay, well, welcome. And what we're going to go through is a problem dealing with how to graph uh, a, a function and given some different constraints with the first derivative and second derivative on different intervals. Okay, so here we go. I apologize for the little smart notebook. This is not an endorsement of them, but it's just right there. So in any case, let's look at this function. We want to graph this. What we know about this function, it's an even function. So if you know about even functions, all right, have symmetry, right, over the y-axis. Okay, so just a little review of that. So if you ever see that, it's symmetry over the y-axis. Okay, so it's also continuous, and it's going from -3 to 3. And it's going to satisfy these following constraints. So the first part right here is talking about x values, and these are the f values. So essentially, these are the y's, all right, that we're talking about. So these are actually points. So we have 3 points they give us right here. And so from here, we're going to graph these 3 points. I'm going to say this is -1. We'll say this is 1. And so every 2 is going to be a 1 value. Okay, so we're going to have 0, 2. So 0, 2. All right. And we'll have that point there. I'll change the color. I'll make this blue right there. Okay. We'll have 1, 0. Okay, 1, 0. And then we'll have 2, -1. Okay, 2, -1 is going to be down here. Okay, so now, given these 3 points, now, because this is an even function, we know this is going to be symmetric on this side. And so we're going to have these values as well. All right, cool beans. Now, from here, it also tells us things about the first derivative. So it tells us at this point right here, the first derivative doesn't exist and the second derivative doesn't exist. It's continuous, so I'm guessing there's probably going to be a corner cusp here. Now, at f of f prime at 1, all right, at this point right here, we know it's 0, so there's a horizontal tangent line. And then we have does not exist again. So this is horizontal. Can't read that very well. I apologize. I have to change my little thing. All right, horizontal. And these are probably corners or cusps. All right, corners or cusps. Okay, at these various different points right there. Okay, I'll write horizontal again for you. Okay, so now, knowing this, we're going to find out what's happening on these different intervals. So from 0 to 1, we see that f is positive. So all our values are positive because this is the graph of f, which equals y. All right. We know that f prime is negative. So if f prime is negative, that means that f is decreasing. And we're always talking about f being decreasing. We also know on this interval, f double prime is going to be positive. So that means f is going to be concave up. We see that on the interval from 1 to 2, f is going to be negative, which makes sense. And then this is going to be f prime is negative, so that means f is continuously decreasing. And then we know that f double prime is negative, so that means f is going to be concave down. It stays negative here, so f prime is positive, so that means f is increasing. And f right here, because it's negative for the second derivative, we know that f is going to be concave down still. So what does this look like? All right, well, first off, when we're starting at 0, we're going to 1. We know this is going to be positive, yes. It's going to be decreasing, but concave up. So what does that look like? Well, concave up, all right, concave up either looks like that or that. Because it's decreasing concave up, we're probably going to have a part that looks like so. So this is going to be concave up like that. Okay, so concave up decreasing. It's going to continue to decrease, but now we're going to switch it and concave down. And that's what makes this horizontal tangent. So it's not a max or min, but it's going to go like so. All right, so now it's going to be concave down. Now concave down and decreasing is probably going to look like that. And so we're going to have looks like this. All right, so we have this nice little, all right, horizontal tangent and then coming down like so. All right, cool. And then from 2 to 3, now we don't have what 3 is, so we can put that wherever we want, but we know from 2 to 3 it's going to be negative, so it has to stay down here. So maybe we'll just say that it goes right there. Okay, it is continuous. So let's say it goes to 0. All right, it's going to be increasing, but then concave down again, So it's going to look this. So we're going to probably go like so. That's concave down like that. All right. And so we're looking at that portion of concave down. And that's an increasing. Now, because this is an even function and on the interval from -3 to 3, we know it's going to be mirrored on this other side. So we're just going to mirror this All right, mirror this on this side, going like so. All right, and then coming up like that. Boom. And that is what our graph is going to be. So this is f, the function f, which is even. It's continuous from -3 to 3. It has these 3 points, which you plotted. Now we understand why this does not exist and why this doesn't exist as well. We can see that corners actually appears to be cusps. All right. We have this values right here, where's the horizontal tangent line. We don't know this, but they're mirrored. And we have all this continuous criteria, which we know about the function. All right. Well, I hope that helps you out in understanding how to graph functions. And good luck and God bless the rest of your problems.